For today's speakers, a quick review of who our 7 speakers are going to be. We've got Eric Elizondo from Milford, Chris Waite from Secor, and Ryan Ruiz from ISCO. These guys are all part of our engineering program, as is our Certified Professionals program, as is Matt Danish. These are 4 of our 7 speakers today. Next slide, Alan. And we also have Dusty Langston, Dave Mosier, and Steve Wilson talking about some very cool projects. You may recognize some of these guys as being regular experts on the Alliance for PE Pipes program. So here's that screen now that I want you to take. Oh, sorry, missed it. Brian Swanson is heading up our bench today, along with John Stevens, Dan Landy, and of course, Alan is in the background. So guys, thank you very much for answering these questions. And to repeat, any question is fair game related to polyethylene today. We encourage this dual track program to occur. Moving on, take a snapshot here. This is how you get a hold of our speakers. Feel free to contact them directly. They are experts, so are we. Contact any one of us. All right, with that, I would like to just give a brief review of these projects. So we've got water main, we've got single family development projects, we've got compression fit, chilled water, so district energy program, a fantastic HDD across the James River. A couple of these projects have been featured on other Alliance webinars, but most of them are new. Well, the Fort Lauderdale has been covered before. So some great content today. All right, so our first speaker today is going to be none other than Eric Elizondo. Eric Elizondo, please come on. Tell us who you are, who you work for, and what your area of expertise is. And then take it away. Let's learn about this Navajo Nation project.
Awesome. Thank you for the introduction, Pete. So my name is Eric Elizondo. I work for Milford Pipe and Supply, wind supply company. I am part of the municipal and water division for Milford. So my job is to go around and help, teaching some of the municipalities about HDP and its adoption, as well as helping our sales reps fulfill these projects and do training for contractors getting involved in HDP and water for the first time. So the project we're talking about today actually is not my project. It is one of our sales reps projects out in New Mexico, but it's an awesome project for us to talk about because of the involvement and the impact that it had. The Tuhajali project in New Mexico was for a small community struggling to have consistent water. So as you can read on the slide there, it's one of the areas in the nation that has the least amount of public water to housing. So in order to fulfill that need, the residents in that area needed to go and find that elsewhere or drive to the spigots to get water. So the PE's involvement and our involvement is essentially to help solve this with a 7.7 mile pipeline coming from Albuquerque on the west side all the way out to this small Navajo Nation. This was obviously something that was deemed an issue by the Commissioner, Debbie O'Malley. They have been searching for some type of resolution, and it had been something that had been on the plate for quite some time in order to ensure that these residents in the area were finding or getting a sustainable water source for an ever-growing smaller community in that area. What ended up happening, go ahead, Ellen, to the next slide, is Souder, Miller, and Associates actually attended one of these webinars back in 2022 about OpenCut and HDP's application in that. From that, there was obviously the sparked idea of being able to conquer some of the environmental issues that were going on with the inclines and declines, and being able to move the water all the way from Albuquerque through to Tuhajali in order to ensure that these communities got water. And so they ended up getting together with the PE Alliance. And one of the reasons I like talking about this is it shows the capability of the webinar serving as a initial starting point for projects that move towards HDP adoption in order to solve long-term issues.
I remember that one in particular. That was one of the very first open cut construction webinars that we did, Eric. And they came to us several years ago and said, "Hey, we've got this cool project where we think this could work, but we're not really sure. Walk through it. All of the excavation, deep part of it was a deep excavation, but you guys did really good. And I'd love to see that municipal cycle all the way back through to the end of it here, where you're really supporting the nation itself to be able to push this along. So thank you so very much for helping them all out."
Yeah, absolutely. And yeah, like to Alan's point, this is one of those things that, somebody came on, had a great idea and was able to get the alliance involved and get, more HEP pushed into the ground. And from that point, basically, the inception of this project started, right? So after that, it obviously went to bid. AUI, which is the general contractor that we ended up working with, after they got all of the rights secured, they got the pathway secured and had a plan, was a new contractor to HDP installation in this manner as well. And so partnering together from, the PE Alliance to the municipality, to the contractor, and lastly, of course, to us, to ensure, appropriate materials, as well as the training for being able to go out there and do fusion appropriately, was something that was, a task that obviously lasted a span of what is now 3 years, from the original time of attending that presentation, that webinar in 2022. But what we ended up doing, there are several different areas in this. They tried to limit the amount of pumps and or valves in this system in order to transmit it that entire length. So in the project, it's really cool to see the different DRs being used, from a DR7 all the way through a DR17, to accommodate some of the issues with the elevation and ensuring proper flow, all the way through to ensure that by the time it got to the nation, that there wasn't going to be a reduction or loss in the volume of water that was getting to them, to ensure appropriate water for the entire community there. So, you see on the slide, we're talking about a maximum of 24-foot burial depth. In that kind of scenario, you want to take into account the wall thickness of the piping. You want to take into account, obviously, the flow of the piping going to the area in order to ensure that it's going to go all the way down. So Milford, along with AUI, went out, got the training completed, got their guys ready to go, and got out and got set up to do this project out in the middle of nowhere. And so it was just a really cool project as a whole for us. Next slide, Alan. For us to see from the beginning stages of having an idea of a need for a small nation, to finding a solution that would complete this task, obviously, the most efficiently and most cost effective, and to see that HDP ended up becoming the most preferred method of doing this, and in an open cut scenario, where obviously you have the option of looking at several other materials to be able to accomplish this job, and yet HDP was the one that came out as top. And so that was some of the reasons I wanted to talk about that project.
Well, I'm glad you did. You didn't talk much about the contractor, but Albuquerque Underground is a very experienced polyethylene contractor. I've known those guys for years, Eric. What was it like to work with an experienced contractor on a first job for Souder Miller and also the Navajo Nation?
Yeah, so there was, they've done a lot in the HEP world. This, I think, was a little bit different than what they're used to. So, it was something that they did have some questions, especially when we were talking in the realm of specs and approvals. We did kind of have a back and forth with their field hands about getting the right information and documentation. But overall, because they had some experience, it was rather smooth, other than essentially paperwork, Pete.
Right. Well, great job, Eric Elizondo. We only had one question come in. I encourage our audience to fire questions at us. We have a deep bench willing to answer your questions. My next guest is Chris Waite. Chris Waite from SECOR up there in Gillette, Wyoming. Chris Waite, good afternoon.
Thanks, Peter. I appreciate it. My name's Chris Waite. I work for SECOR out of Gillette, Wyoming. I in charge of outside sales and product development, or project development with different municipalities along many different market segments. The project we're going to talk about today is a single-family home subdivision that was 36 lots in Pinedale, Wyoming. I teamed up with Mickey Lavoie, who's down in the bottom right of this slide here. He called me. We chatted about everything. This project went really fast to get through with Abram Pierce, myself, the city, the contractor, everything to get this rolling. The whole thing turned around in a sum of about 2.5 to 3 weeks to get ready to start installing all of this. The team up there is key and getting everybody on board and everybody on the same page. And we did that with the help of Dustin Langston at WL Plastics and my team going down and meeting with all these guys, and just did a lunch and learn kind of like this webinar, but it was live. And they had all kinds of members from the municipality there learning about what we could do on this project. Next slide, please. What it was an open cut install. We did approximately 2,000 feet of 8-inch DR11 water. We did approximately 1,800 feet of 8-inch DR17 gravity sewer. Thing to keep in mind on the gravity sewers, we did have to debead that, so it took a little bit longer. But we did get this entire project, you'll see it in the video at the end, set up, installed, backfilled. They were dumping or putting asphalt on the ground and building houses by the time we got to the end of the line to where they could start selling these lots off. This is a little town that we're dealing with, but we were dealing with depths of only 7 to 9 feet. But as you can see in this picture behind the guy doing this tap, the groundwater was really high in down here. So we had to ballast the pipe and get it to sit on the ground at grade and then backfill with our aggregate and go from there. Next slide, please. A few pictures from the project you can see here. We ran all AVK Series 66 valves. Great solve to not have to run mechanical connections. Concrete manholes, all the sewer. They kept everything. When they cambered it, they found one spot in 1,800 feet that had about 1/4 of an inch of water in the bottom of the pipe. That's how tight of a spec that the contractor maintained on all of that. The other nice part about the HDPE in this situation is EPA stated that we had to be 10 to 12 feet apart with the Bell and Spigot legacy material. Once we proved to them on the HDPE, they let us go down to 6 to 9 foot separation on this entire project, which made the excavation a lot smaller and helped us out quite a bit there.
Hey, Chris, you talked about the AVK Series 66 valve. Tell me what makes that different from the traditional AVK seated gate valve?
Yes, sir. So the AVK Series 66 valve is actually a fuse in line gate, AWWA gate valve. They press I don't know their exact method of, they press that pipe on, they put stainless steel rings around it, they wrap them, and there's no mechanical fitting there whatsoever. You just butt fuse it right in line, or you can electrofuse it however you want to do it. It's a great solve to keep mechanical connections out of the ground, which every mechanical connection can become a leak point at some point or another. Next slide, please. Some of the obstacles we had to face with this project, the city of Pinedale, the frost gets drove in the ground super deep. They've seen it upwards of 78 inches. So they were having to go back in through their services and steam the line out because they would freeze up. So to take care of that issue, whenever they're running service lines, they're actually putting 2-inch blue board insulation right above the pipe after they backfill a little bit to keep that frost from driving down so deep in and freezing those service lines. The main lines weren't as bad. The town itself was running 15 to 20% water loss. Obviously HDPE is going to cure a majority of that, and their sewer infiltration was atrocious. They were selling approximately 500,000 gallons of water and taking in 1.2 million gallons of sewage into their sewage treatment plant, which was huge. That's why the HDPE was decided upon, so we didn't have any infiltration problems. This is just a typical installation that we were dealing with. There was a cul-de-sac in this, and we ran everything around, so it was a complete closed loop system, but they had the ability to divert and shut the cul-de-sac out if they had to do a repair or anything like that. Next slide, please.
Here, right here, we did just do this was all completely wide open, right? So we fused this because we had.
So Chris, that's showing your Series 66 up close. What's that light blue pipe? Are you doing a pressure test right there?
Yeah, so that's how we filled the line to pre-chlorinate and pressure test ahead of the line being put in service, which was extremely nice because you can do that with all polyethylene. You can pre-chlorinate and pressure test above the ground. Or you can have it in an open cut situation like this and have it sitting there and pressure test and pre-chlorinate right there. But that blue line we actually ran from a fire hydrant down to chlorinate with the city's already chlorinated water. And they gave us a chlorine spec that we had to meet at the end of the line, and we met that spec and let it sit that way, and they were good to go and put it all in service. Another picture of a tap that this is how we were tapping the lines. We used integrity saddles with 1-inch corporation stops that were compression onto HDPE. Yes, it's blue, but it's still HDPE SDR9 service line, 1-inch CTS. Here he's actually going to tap this line in a live tap format.
Yeah, Chris, we haven't shown this ever in the webinar program before. So this integrity saddle, we call that a electrofusion corp saddle. So it permits the owner to put a corporation in there. So this line is charged. And with that drill, he's running that drill bit into the wall of that polyethylene pipe. And I guess, Chris, it retains the coupon as it comes back out?
Yes, so the cutter actually holds the coupon when it comes back out. They'll pull that up inside. You can see a little bit of leakage coming by. He'll close that corp stop, but that coupon's up in the cutter. So when he pulls that cutter out, he'll have to take the coupon out of it. He'll just screw his tap tool right off of there. He'll purge the line. Hopefully they purge the line so they're not shoving any little potential shavings and whatnot like that up into the service line and into the meter. Again, you can see how close the water and the sewer were. These are actually running right in the middle of the roadways. Great situation here for an open cut installation.
Well, actually, in actual fact, the elevation, Chris, of that sewer is higher than the elevation of the water, which is something unique, and which I just love that you educated Pinedale enough so that they could do this with confidence, because neither one of them leaked. So I guess it really didn't matter. And just to add, Chris, you called this a little town, but it's a town that's really growing pretty quickly just south of Jackson, Wyoming.
Yes, sir. So the developer that's doing this actually has some more projects on the horizon, and he gave me a rough number at one point that he was going to more than double the town's population in the next 5 years. So it's going to be a very sizable town, and obviously Jackson, Wyoming is spreading out. So eventually it could be where they're one of the bigger municipalities. Next slide. So this video kind of speaks for itself. This just shows you how resilient polyethylene is. I got to jump in the Traco and run this over just to show. And in the middle there, you can see.
Wait, hold on a second. Alan, could you click on the play button? Actually go on the screen and click on play, because it's buffering.
In the middle of this, right close to the middle of the track, we actually have a fusion there where we made the fuse, let it cool the minimum amount of time we possibly could, and took it out of the machine and then ran it over with the excavator.
Yeah, this falls under the category of let's not do this at home. But Chris was kind enough to get in that excavator and drive over it. And then, we just brushed it off to show the fusion and also show that the tracks really didn't damage the polyethylene. Now, Alan, we do have rules, and these kind of violated the rules for compressing on the polyethylene pipe. Am I right or wrong?
You're absolutely right. What's going on is if I type an answer, Pete, and the video is on, then it just distracts to it. My phrase for this was like, why would anybody want to jump out of a perfectly good airplane, right? We have a perfectly good butt fuse joint. Let's keep it going. But you can fully include the idea of the pipe by squeeze off. If we go down at a specific set time period for the DR and the size of the pipe, and then we let that squeeze off relax through another time period. As long as we don't violate those two time periods, then we do not damage the pipe in that manner. It's oftentimes used very much so in the gas industry itself. But gosh, look at the just visual alone. You guys, part of what the Alliance and Chris does is come up with all these really cool things to do, and you certainly did overachieve, and that is a true compliment, Peter. So good job.
Oh, thank you, Alan. Well, Chris, great job on this. I think we've got Mickey Lavoie to finish, but we need to move on to the next one after we hear from Mickey.
Hey, what's your name is?
Mickey Lavoie.
Hey, Mickey, who do you work for?
I work for it's my own company, but I'm hired to do this project for Jason Moyes.
What advice do you have for other superintendents across the U.S. that haven't used poly yet?
Just first off, get somebody that's knowledgeable. One, like Secor, get somebody that's knowledgeable to sell you the pipe, sell you the equipment and that, and it'll help testing your guys. But the biggest thing is you got to get somebody that knows it and is comfortable with it, because you're going to have the town, engineer, people, everybody's going to be screaming, because it's always been in the commercial and industrial side. It hasn't been on the residential side yet.
So, what is your time on a job site with poly for your infrastructure versus PVC or ductile iron? Is it less time? Is it more time?
Oh, it's a lot less time.
How much less time?
I would say on this job, I probably cut it by 2 months.
How many homes subdivision is this?
36 home subdivision. I've got 1,850 feet of sewer and 2,000 feet of water. That doesn't count the services, that's just the main.
And then is the pipe more or less expensive than PVC?
It's less expensive, way less expensive.
Hey, what's your name is?
Well, Chris Waite, great job. Thank you for sharing that, Pinedale, Wyoming. Chris, you're always welcome on the webinar program. Thank you once again.
Thank you. We had one quick question that come across and I hit answer live on it. They wanted to know if the sewer line was pressure tested also. They did a gravity fill the manhole situation on that to make sure there was no leaks in the sewer system at that point, even at the manholes.
Okay, so that was a gravity sewer that might connect up with a force main outside the subdivision?
Yes, sir.
Got it. All right, great job, Chris. Now, with no further ado, my good friend Ryan Ruiz. Ryan, welcome to the Alliance's webinar program, and you're going to talk to us about Fort Lauderdale.
Yes, thank you, Peter, for the introduction and having me today. My name is Ryan Ruiz. I work for ISCO. I'm a regional sales manager in Texas these days, and I focus on the industrial and municipal markets for polyethylene. Today, we're talking about an emergency force main. It was 54-inch and 48-inch DR17 pipe and fittings in the city of Fort Lauderdale. This picture, these two pictures here are just to give everyone an idea of the geographic challenges that were on this project. You got roughly 165 miles of waterways here, including canals and ditches and things like that. So between December 19th and between December 2019 and February 2020, the city of Fort Lauderdale experienced a lot of catastrophic breaks in their force main, their sewer force main. As you can see here, there's a large amount of pipe missing there. And then on the right just gives you an idea of these catastrophic failures, the areas that they were in Fort Lauderdale. Over 211 million gallons of sewage spilled into the waterways and canals. They had vac trucks working 24/7 for close to 5 months during this to help remove some of the sewage that was being spilled into the city's force main. So Emergencies typically always happen around Christmas, New Year's, Thanksgiving. It's never a good time. As you can see here, December 23rd of 2019, their city manager made a call and quote unquote said they want the fastest pipe ever to be installed in Fort Lauderdale. So in order to do that, ISCO teamed up and invited a group of qualified design build firms to help with this. It basically a design build type opportunity project here. Next slide, please. So I mentioned 2 teams were selected. Basically broke this up into 2 sections or 2 phases. You had a north phase and a south phase, roughly 38,000 feet of pipe, $65 million in about a year and a half worth of construction here. You had the city of Fort Lauderdale, and then teaming up with Murphy Pipeline and DM construction groups and engineers to come up with solutions. A lot of trenchless solutions and some open cut. But let's next slide, please. Yep. So the project here, looking at the map here, highly urbanized areas, a lot of homes, a lot of businesses to work around. Like I mentioned, 38,000 feet of 48 and 54-inch DR17 pipe. Had 17 HDDs. Most of this project was trenchless, some as deep as 60 feet on some of the directional drills. And then as you can tell here, being in these urban areas, you have very limited right-of-ways in order to do these projects or these pieces of the project. So why HDPE? Get that question a lot. So here in the Fort Lauderdale area of Florida, high salinity in the ground, right? Very corrosive environment. HDPE is very abrasion resistance, right? So reduces any scouring that could happen to the material. Another huge thing was the ability to manufacture custom-made fittings on site, which we'll look at here in a little bit. There was, some prefabricated options with HDPE, or a lot of prefabricated options. But what made polyethylene great for this opportunity was the ability to make custom bins and fittings on site. Also, HDPE is considered jointless and restraint pipe, right? So allowed for less clearance from other utilities.
One of the unique parts of it is it's also leak free. So in many instances, the spacing that we put between a gravity sewer system and a potable water system or vice versa is dependent upon one leaking into the other, and we simply don't want that to happen as well. So we had some questions previously about leaking and other things, and it's a leak-free product. So keep going, Ryan. You're doing great.
Thank you, Alan. Mentioned majority of the job was trenchless applications, 91% to be exact. There were 17 directional drills that helped avoid DOT roadways and things like that. This project also consisted of some of the compression fit lining of pipes that were failing. So pretty amazing stuff going on here. You can see 54-inch, right? 3,100 feet of 54-inch shown here on the left image. The 48-inch, 2 examples here. One very impressive one in the 2,600 feet of reverse compound curve that the driller made here. Pretty amazing stuff. Some pictures of job site conditions, whether it was fusing and laydown areas. Here's a picture of a fusion operation in a very limited right-of-way in this urban area of Fort Lauderdale. They're basically building out strings of HDPE pipe, preparing it for trenchless installation. Next picture. Yep. I mentioned this earlier. HDPE is fully restrained, right? So there were no need for mechanical restraints. These are butt fusions that are as strong, if not stronger, than the pipe itself. So there's no need to install mechanical restraints on this job. This picture in the bottom shows a directional drill that was made up 60 feet deep, 1,600 feet long, under seawalls, environmental permitting through the United States Army Corps of Engineers. Just incredible opportunity here for HDP to excel and create an awesome solution. So I had mentioned custom-made fittings, or the ability to make fittings on site, right? Miter pipe and fuse it together to make custom elbows and things like that. So these two pictures shows examples of that, shows some of the utility conflicts that existed on the job, right? So, in these open cut applications, just because we were able to open a trench doesn't mean that we were allowed to just set the pipe into the ground. We had to navigate these utility conflicts throughout the project.
Hey, Ryan, one of the concepts I've heard you talk about is the issue of equivalent dimension ratio as it relates to fabricated fittings. Could you briefly share with our audience why that's an important concept for all of us to understand?
Absolutely. Yeah. So, when engineers are designing projects, one thing to look at is the pressure rating of the system, right? What do we need to meet in regards to that rating? So, for instance, DR17 HDPE pipe is pressure rated for 125 psi at 80-degree temperature and lower. When you're dealing with fabricated fittings, you have to derate that fitting. So, if I were to make a 45-degree elbow, like the two in this picture to the left, if I make it out of the DR17 pipe, what we call feedstock, and fuse it together to make that elbow, I'm going to have to derate that fitting lower than that 125 psi rating. So what we do is we'll make the fitting out of a larger, not a larger diameter, a thicker wall pipe, so a lower DR, in order to allow for that fitting to be fully pressure rated. So it's a
Brian,
question.
I'm gonna pop on here for two that we had that were great. So everybody on the call, you're really thinking about it. I love the questions. How is the utility clearance completed for 90% HDD down urbanized streets, potholing or hydro excavation every crossing? So a lot of times with this size of pipe and horizontal directional drill, we want to try to establish a safe spot location for it. And so that would be underneath quite a bit of other utilities, in which case this utility would occupy that particular space. Obviously, data collection is extremely important. We need to know where all the other utilities are, especially when we're crossing them, to get down to that bore path. But a significant amount of effort was able to be executed quickly to be able to identify the safe location for these as well. Potholing and Hydro-X, we're definitely involved in those processes as well. So how did you maintain access to the homeowner during fusion and pullback? That's another great question here to be asking. In some places, there's redundant streets as the block moves forward and block moves forward again, as to which that homeowner can be provided access on the other place if the center street's going to be used for fusion. In some trenchless applications, we're going to pull from a laydown yard to the actual insertion pit when we're using that. And that process can be a very short time period, as to which those impacts aren't going to be pretty bad. So keep going. You're doing great, Ryan. We are cruising.
All right, yeah. So just these next couple of slides are just example of these custom-made fittings, right? And just the interferences, somewhat headaches, right? When we're trying to remedy these issues, you have all these existing utilities that are conflicting with our work areas. So being able to custom fabricate fittings and spools on the job was very crucial. One in particular that wanted to call out here was very limited right away. This picture on the left shows custom-made fittings fused onto pipe, right? We call this an HDPE prefabricated spool. This is a above-ground pre-assembly of this 54-inch line. And then the picture on the right is where we actually we sink the pipe using a attached concrete pole as a ballast. And again, this was due to some limited right-of-way issues that we had. We ended up making a prefabricated spool for installation on the job site, all done right then and there in the city of Fort Lauderdale at this project site. So corrosion resistant, H2S resistant. I mean, these are 8 reasons why this opportunity to rehab and repair this emergency job it came about with the solution of high density polyethylene.
Well, great review, Ryan. You know, Fort Lauderdale has taken the lessons learned from this project and they've begun using polyethylene to a much higher level. In fact, most of this was 48 and 54-inch DR17. They now have done the second time this has ever been done, 54-inch DR11 job in Fort Lauderdale. So great job to ISCO and Chen Moore and Murphy and DMSI for pulling this together and basically saving the day in Fort Lauderdale. It's amazing what polyethylene can do. Great description. Thank you so much, Ryan Ruiz.
Thank you for having me.
All right, moving on. We have a good friend, another good friend here, Matt Danish from Agru. That 54-inch DR11, Matt, was made, I think, by Agru.
Yes, that's correct. We made the pipe for that project. They needed the wall strength for it. And we just came on board with making that product in the last year and a half. So something new to the market and definitely a great application to use for that project.
Yeah, pretty exciting stuff. And your pipe's going to be featured here again shortly, Matt. So congratulations on having the technical ability to make high pressure polyethylene, so 200 PSI up in those larger diameters. Well, Ryan Ruiz and I are down here in New Orleans today, and you're about to feature a project right here in the wonderful city of New Orleans. So take it away, Matt Danish.
Yeah, okay, so this project was the South Claiborne transmission main, both a 48-inch dips pipe and a 30-inch dips pipe. Actually, those are smaller sizes that we basically did a compression fit. The existing line was cast iron and ductile iron that has just been failing over the years. And the city has just been plagued with issues with the line. And they just made a decision to go ahead and replace the line with HDPE. It was a very good decision. This compression fit uses the existing line as a hose pipe. And if we go to the next slide, we'll talk about the compression fit. Next slide. So basically the project was after the Hurricane Katrina wreaked havoc to New Orleans infrastructure. And the amount of cost that the storm did was overwhelming, but it wasn't just the storm that did it. They had issues with corrosion that had been going on for a while. And with the storm and the additional amount of moisture in the ground and ground movement caused a lot of the lines to start breaking, which caused them to have issues with leakage, shutting lines down, which would bring in infiltrated water. And the boil orders that the city had to have ordered were just incredible. I'm not sure if people on this line can understand the issues with the boil order. Whenever you have to boil your water, it's a tremendous pain to the residents who have to take their water and boil it before they can drink it or use it in any type of application for consumption. And so being able to come up with a solution for them
So, Matt, it's not just the residents, but also the restaurants and everything else.
Restaurants everywhere, right?
Yeah. So it's definitely in New Orleans, that would be a massive impact for a boil water notice of that. I'm glad you pointed that out because that's a social aspect of pipe failure that is not often thought about. It's mainly thought of as an afterthought, and you have to live through something like that to be able to fully understand it. So that's definitely a great observation, Matt. Keep going. Good job.
All right. So yeah, the city was looking at alternatives, what they can do to fix their problems, because it wasn't just the broken lines were running underneath city streets. They were having cars falling into holes from the broken water lines. And so to rectify the situation, they launched a massive project to replace their 100-year-old water transmission lines with modern piping systems, which HDPE came to mind. since they have very limited access to the right-of-ways, and they couldn't just dig up the existing pipe to replace it. So a very cost-effective solution for this project was to do what they call a compression fit. That is where you're basically, next slide will show the compression fit for this material. The reason why compression fit was used is because it has a ability to use the existing pipe, and you basically pull in a new pipe of HDPE into the old pipe. It has a tremendous amount of pulling force, but we were able to do about 1,200 feet at a time with this compression fit. The compression fit is basically you're taking a smaller diameter pipe, or a pipe that may be at the same ID size as your existing pipe, and it's compressed, meaning it's being pulled under stress using a orifice or ring chamber to basically reduce the size of the pipe as it's being pulled. And this technique was studied for this project, and it was something that they definitely figured they could use because it minimizes, biggest thing is minimize traffic for such a busy city with very limited access. Being able to have long strings of pipe, being able to be pulled all in at one time, basically minimizes the amount of footprint that's being disturbed. Next slide. Oh, this should be our video showing the project. So on this project, the compression fit line is basically a HDPE pipe that's pulled into the existing pipeline, and it goes through a orifice chamber, a ring chamber, that basically holds the pipe back and stretches the pipe and reduces its diameter so it can be pulled into the host pipe. And as it's being pulled into the pipe, it's under tension. So basically it contracts in its OD so that you're able to pull it in a larger pipe into a smaller area. And as you let it set over time, it will actually expand back to its full diameter. And that process then allows you to maximize your inside diameter. So as this, you're seeing here, they're spraying water on it to cool it because it does get a lot of heat when it goes through the that orifice ring. And it also acts as lubricants for spraying water on it. And when it pulls it through, then you're able to have a pipe that actually is the best fit for your existing pipe. And this is showing the pipes that are being prefabricated, ready for pulling through the line. And this process is somewhat quick. You can pull it, as you saw the guys spraying it down, you're pulling it at a fairly decent rate. And every 1,200 feet or so is where we had to come back in and do connections. Next slide.
So before we go on to that one, Matt, this is a great opportunity to answer a couple of good questions. The existing pipe material that we're looking at to use compressive fit slip lining happens to be something that we can clean all of the tuberculation out of, but not necessarily pipe burst. So we're not going to be able to fracture that pipe. Otherwise, you'd use pipe bursting. We were asked if you could compression fit corrugated metal pipe that is heavily corroded. Oftentimes, that pipeline has jagged surfaces through that. And the problem about replacing corrugated metal pipe in place is there's not ample hoop strength in order to be able to shear and break it easily. So we're not even going to be able to pipe burst CMP. If you have room, what we'd look at more as a slip lining, we really don't want that to be able to push up against the corroded surfaces of what we're looking at for CMP. Great questions out there, everybody. You're doing
Yeah,
really
that's a good question because basically, yes, your host pipe has to have some type of structural capabilities to hold the resistance of the pipe as you're pulling it in. So if it's a pipe that does not meet that criteria, then you have to do a slip line, where meaning the pipe is smaller in OD than your IED, so that there's no drag forces that are being established from the pulling forces of the pipe going through. So yeah, when you talk about the long-term solutions, HDP, the corrosion resistance, the flexibility, the durability, the lower seismic susceptibility. Let me just jump on the seismic. Seismic is also related to ground movement, because In some of the areas, we did have ground movement, and that does cause problems with other pipe systems, especially if they're slip joint or whatever, they could be coming apart. So the seismic can also be attended to stability in soils as far as your sinking points or points that cannot handle the geological formation movement. The eliminating of leakage and low biofilm, that is something that's just part of HDPE. HDPE, when you butt fusion weld, is a 100% leak-free system. And HDPE also provides a low biofilm formation. Basically, that's because the surface is so smooth that the HDPE, there's not much that can stick to it. So it cannot build a large biofilm like other materials of steel, concrete, and so forth. Preserve water and water quality transporting. So this is interesting because what we're seeing now when you have a system that's all HDPE, what we're finding is that the water quality is better, meaning you don't have leaching out of metal, rusting, and things like that. But the other thing that it does is it minimizes the amount of chlorination or disinfection that has to go into the water. And so when you have a system that's all HDPE, you will know over time that you don't have to use so much disinfectant to get to the end of the pipeline to still maintain some minimal carrier of the disinfectant in the system. And that definitely then will improve the water quality for the end users because they don't have to be smelling the disinfectant chlorine or whatever is being used in the final product. It'll minimize the amount. Oh, I think we went back too many slides.
Well, Matt, that was great. Thank you for educating us. You know, we had another video of a compression fit that Murphy Pipelines did in New Orleans years ago, where, you know, we've been showing that one for years. It'll be fun to have a new video to show our audiences from compression fit. That just for the record, we used to use the phrase swage lining, but now we call it compression fit, and everybody's pretty consistent on that use. So Matt Danish, fantastic work. Thank you for sharing that, and keep up the good work down there in Charleston, South Carolina.
All right, thanks for having me.
All right, next up, we've got 3 left. This webinar will run for 75 minutes today. So we've got 3 left, and we've got quite a bit of time left. So we're in good shape. Dustin Langston, you're here to talk to us about a product in Alberta.
Yep, absolutely. So this is the South Red Deer sanitary project for their sewage treatment plant. And this is a very large spread out area. It doesn't have a lot of population to it, but there is a lot of population or small towns around the area. So it is a central wastewater treatment facility for several communities in that county.
Hey, Dusty, before you get started,
in Alberta. Yeah.
May I interrupt? Would you please introduce yourself and tell us a little bit about who you are, what you do, and a little bit about your involvement with the Plastics Pipe Institute?
Yeah, absolutely. So my name is Dustin Langston. I work for WL Plastics, one of the larger manufacturers of polyethylene pipe here in North America. I've been with WL Plastics for 20 years, currently VP of Engineering and Quality Assurance. I am also a member of the Plastic Pipe Institute. Many of the people on this webinar are members, but the Plastic Pipe Institute is kind of the technical arm of the polyethylene pipe industry, where we do all of our really heavy lifting in the industry. So if there's something that we need to learn about or something that we need to really do a deep dive on to fully understand the product's capabilities, that's kind of where that work starts. A great example of that is for chlorine resistance. To fully understand HDPE pipe's chlorine resistant capabilities and to then improve them, we really started that work within the Plastic Pipe Institute. That took several years to complete. Nowadays, you'll see on every single piece of PE 4710 polyethylene pipe, you'll see a little 3-digit character called CC3. That is a chlorine categorization number. So that is work, again, that started in the PPI and now has been fully adopted throughout the entire industry, including the American Water Works Association. That's who actually dictates that we put that little CC3 on the print line. And that's just ensuring that you're getting the highest chlorine resistant pipe possible for your project.
Hey, Dusty, we got a an interesting question that includes a compliment, but hopefully doesn't have, the wrong answer for this gentleman itself. But he goes, does WL Plastic still support their computer desktop calculator and application? I've changed my computer twice and since lost that application. Would love a link to download again if possible. If it's no, sorry, Robert, we're going to disappoint you, but the praise is definitely there, and you can tell that Dusty wishes that calculator was around if it's not. And if it
I
is,
do, and I wish we still had it. I'm so sorry. The answer is no. It has been replaced by the Plastic Pipe Institute S5, which is the hdpeapp.com. It's an online calculator. It's a great calculator. The usability of the old WL Plastics calculator, I totally understand. It was so good. It was just the easiest to use. And so I do still, it's been out of publication now for probably 8 years, I bet. But I do still get requests for that download. So sadly it doesn't exist anymore. All of the capabilities that calculator had, the S5 PPI calculator, it also has those capabilities. It's just not quite as user friendly. But yeah, make sure to check out that new calculator. And if you ever want to contact me or anyone on the PE Alliance, they can run you through how to use that calculator. But that is a great compliment, and I do get the request still quite often. So go ahead, Alan, next slide. So the Red Deer water system or wastewater system is a huge system. We're talking over 90 kilometers of pipelines, the majority of which are actually pressure. So we're talking force main applications, and we're not talking, much gravity sewer. All of the new additions that were performed were done in polyethylene pipe. And they've really built it out to be able to handle future growth in that area. Alberta in general is a growing province. There's a lot of people moving to Alberta. There's a lot of great economic opportunity there. So it's very, very common. It's kind of like the Texas of the US right now. A lot of people moving to Texas. Same for Alberta. So the majority of the pipeline was DR17, and diameters all the way down to 16 inch, but all the way up, 30, 32 inch. It included 120 wetland crossings, 10 creeks, and dozens of road crossings. Anytime we went to do a crossing like this, the main reason polyethylene pipe was chosen was for directional drilling. HDPE pipe is the #1 directionally drilled installed pipe in North America. It is way more than half of all the installations is HDPE pipe. And so that was the main reason it was chosen for this project. Along with that, frost line, heaving, and then being able to follow the land without having to use any fittings. This is a lot of very hilly country, and it's a lot of open area. So there's a great opportunity there for polyethylene to kind of move with the land and not have to have any fittings in it.
So Dusty, I recall Brent Penner and his Fusion Techs played a pretty important role in this job at Sandale. Is that correct?
That is correct. So pretty much any of the big tie-ins, the contractor themselves, they came in and did a lot of these fusions. But anytime they did a drill and they had to do any kind of connection or any kind of electrofusion, that's correct. Sandale and Brent Penner's team really stepped up to the plate and helped these guys. This was a multi-year project. It was a really, really big project. So one of the biggest ones is the Highway 2. They call it the Deerfoot 2, and having to go underneath that. That was a big part of, or one of the big worries, is how do we get under this road with HDPE pipe? There are a lot of options. Some people will actually directional drill a steel casing first and then put HDPE pipe through the steel casing. But this is another great method here that we're actually going to use a bore. So instead of using a directional drill, we're just going to excavate down to the depth that we want our pipeline to be. We're going to kind of jack and bore and do a steel casing under the highway, and then we'll just sleeve HDPE pipe into that. So that was, again, done, no disruptions to traffic above. They were able to completely install that section and not shut down or slow any traffic, which is good because they get about 40,000 vehicles a day across that Deerfoot 2. Just to give you a heads up, Red Deer is about halfway between Calgary and Edmonton. So there's quite a bit of traffic up there. Winter weather. Anytime I get questions about, especially people, Texas, Oklahoma, oh, it's below freezing today. Should we be shutting down our job sites? I always just kind of chuckle. I'm like, we got guys in Canada, North Dakota, they install this stuff all winter long. So when things do get very cold, you know, this particular project, they were welding pipe in the winter when it was negative 30 degrees outside. So anytime you get into those very extreme colds, you do kind of have to think outside the box, or in this particular case, inside the box, because they wound up using shipping containers. They actually built out a shipping container with the fusion machine inside of it, and then they had heating inside of it as well. You can then couple this idea with preheating of joints. So instead of bringing in a super cold joint, you'd actually put some kind of either a heating blanket, or you can even use like a propane heater, but just make sure you're setting it far enough away from the pipe that you're not, you know, potentially hurting or damaging the pipe from excessive temperature. Kind of the rule of thumb there is if you can stand to stand in front of the heater, that's the distance you need to have it at least away from the pipe to be able to preheat it. And then once it would go into the fusion trailer or the shipping container, it's heated in there as well, and they perform the fusion just as if it was a nice warm sunny day outside. So it was a really, really good a way to do it. Again, these were very large pipe diameters, so these pipes weigh a lot of, they're pretty heavy. So 256 pounds per meter for the USA people like myself. I want to say this pipe is like, it's like 86, 88 pounds a foot. So, you know, the weight of the product is definitely something you need to take into consideration. Here on the right-hand side, this is a track hoe that has a special built cradle to be able to run that pipe into the trench. So they'd be able to actually cradle that pipe, move it into place, and then lay it down into the trench without potentially, you know, scraping it up or gouging it if they were to have used like a wire rope.
Hey, Dusty, we had two good questions. Is there a concern with locking the HDPE pipe within the casing given thermal expansion properties of HDPE? I'll give you a softball there. You know, we're looking at changes in the thermal temperature in between it. And then on the edge of those casings, we're going to look at terminal connections that are reinforced terminal connections and restrained connections, correct?
Yep. So in that particular case, there's really two ways of thinking about it. You can use spacers to centralize the HDPE pipe in the casing pipe, or you can use some kind of a grout. If you use a grout to grout the annular space between the two, that can be done. It's a little less common. Spacers, I would say, are probably the more common of the two. But in either case, when exiting the casing pipe, you need to make sure that you're not creating a shear point. If you were to lay the HDPE pipe directly on the bottom of the steel and you did not have a footing exiting that casing pipe, over time, if you got soil subsidence, you could put a shear point between the HDPE pipe and the casing pipe. So it's very important to keep that in mind, to either put spacers so that you don't get that shear point, or to put some kind of a foundation exiting the casing. Now, when we're talking about thermal expansion contraction, again, either way, if you're using concrete, the concrete's going to hold it still. It's not going to be able to expand or contract. And if you're using spacers, it's not really going to be able to expand and contract either. And if it were to, it would just kind of fit tighter up against the hose pipe, the casing pipe. Either way, it's not hurting the polyethylene pipe at all. But yeah, that's a good question. We did a project here in Salt Lake City, Utah. Utah's where I live, where we did the very similar under I-15. And they use spacers on that project. No footings exiting, just using spacers. But yeah, thermal expansion contraction, we're not worried about that. But yeah, so in total, you know, this was over 22 contracts. It was a huge project, $140 million project, won several awards in Canada. And it was, again, it was done without a hitch. It went really well. Oh, actually, that's a lie. We had one hitch. We had one of these pipes was laid right next to the road, and there was a huge car accident. It was like a 3-car pileup, and they hit the pipe because it was right by the road. So a car got knocked into the pipe, and they had to do one repair before they directionally drilled that string in. So I will say that that's the one hitch that we did have was a car accident damaging the pipe.
Well, great job, Dusty Langston. And I guess they used WL pipe on that project. Is that true?
Well, yes, they did.
Yeah, of course they did. All right, Dusty, great job. Thank you. And we've got plenty of questions to keep you going. So, Dusty, please hit the bench and help some of those guys. All right, Dave Mosier, Core & Main, welcome.
Yes, thank you for having us here today, Peter. I am Dave Mosier with Core & Main. We're one of the largest water wastewater distributors of pipe, valves, and fittings. We've been in the poly business for about 20 years. A lot of the projects we've talked about today have been very large in scale. We're going to kind of micro that down here on this project. We talk about this expansion in Frederick Hospital. And Mickey LeBoy made a great suggestion earlier. Not only do you want to qualify your contractors on your projects, you also want to qualify your distributors. I would say you could easily do that by asking that the distributor providing your pipe is a member of the PE Alliance. I'm here today with ISCO and High Country and Secor and Milford. I have a great deal of respect for these distributors as well, and the gentleman that has spoken to you, because we all have a shared commitment to the training and innovation that we can bring to ourselves and to you through the PE Alliance. So thanks again. So we can go on the challenge here. We're going to start expanding the chilled water system for here. Frederick Hospital made a commitment a number of years ago to go to the polyethylene, to go to a leak-free solution for their chilled water. Completely bought in on this. And when they put in these pipes that we're tapping into here a few years ago, they sized them to allow for this expansion. So the time came for this new building to go up, and how do we pull the water off there? We don't want to start bringing mechanical ideas in here. So a lot of what's going on here in the last dozen years that I've been involved is that we see a lot of innovation in the market. Our suppliers have brought us a lot of cool new technologies, and they've revised some of our fittings so they can work in bigger and better ways. So we've got 28-inch main line here. We've got to pull 20-inch pipe off of that. Got to tie it in. Well, what you're seeing right there is a product made by Strongbridge International, and that is a 20 by 28 electrofusion saddle. And you may have seen some small ones earlier for pulling off of water services. This is taking that to a whole nother level. So you do need to work with people who have been trained and have a great relationship with their suppliers. For this project, my two technicians, you see there, Ben and Mike, traveled down to Jacksonville and were trained on how to install this. They did it before they got started, installed a temporary bypass so we could vacate this line. But you'll see there that fitting as well as this spider tool that we get also through our vendor here, Strongbridge International. Now the challenge, if we go on to the next one, is that they've designed these fittings to go on vertically, coming up off the top of the pipe. But that's not the real world. In this case, they had to go down at an angle. You'll see that we've cleaned off the pipe there. A couple things you'll see here, it's darker in color. We've removed about 7/100 of the top surface of that pipe in order to remove any oxidation so that we get a good bond when we melt two virgin surfaces together. You'll also see that there are some rerounding tools. That's what those clamps with the orange, the orange straps are. We're bringing that pipe into perfect roundness so that the fitting, which is made to a perfect roundness, actually fits snugly and correctly on the pipe. Like I said, my guys traveled down there. Since these had never been done in a non-vertical application, the technical people from Strongbridge actually traveled up to Milwaukee to participate in the project with us as well. You'll see here now that we've got these extended down in 45-degree angles off the main line, and then we had to take a regular butt fusion machine, take it down in the ditch, and fuse the rest of that on the line that's going to come off of that. One thing I'll note is that before we cored out the holes, we actually put a cap on these and did a low pressure air test to assure the integrity of that electrofusion connection. And obviously they passed. But a couple of days of work, long days, but great partnership with our contractor on this. And again, that owner just saw the value in a completely leak-free fuse system.
Well, I'm sure you played an important role, Dave, in educating the owner about there was actually a polyethylene solution for their need.
Yes. And it was one that we honestly hadn't used before, but we were aware it was there, and we immediately committed. It would have been easier for us to try to promote something else, but it really was the best thing for that application. So we took the time and the expense to get ourselves educated, and did a great job for them.
Well, great job, Dave Mosier. Thank you for sharing that unique application of medium diameter, I suppose, not large diameter, but medium diameter electrofusion saddles. All right. With that, Dave Mosier, Core & Main, thank you so much. Welcome, Steve Wilson from High Country Fusion, to the Alliance's webinar program.
Hi, everybody. Steve Wilson here, High Country Fusion. I'm here today to talk about the Hamptons Roads Sanitation District James River Crossing. This is actually an active project. It's still going on. What we're going to talk about primarily here is the 42-inch SDR11 horizontal directional drill that took place under the James River. So the James River waterway is the 6th busiest harbor in the United States. The Hampton Roads Sanitation District has a SWIFT program where they are taking all of the old sanitation plants that are now losing their ability to treat water because the water is rising, and they're moving this into new updated plants where they're going to take the treated water and inject it back into the groundwater and create more water for their aquifer. So this originally started as only about 3,400 feet of 42-inch line that was going to go in. They came up with a way to extend the line. Instead of having a water-to-water horizontal directional drill, they did a water-to-land horizontal directional drill. They added about 2,400 feet to it, creating this 5,700 total foot length of the actual drill itself. That little tweak that they did saved them $10 million from the original bid. So the only way to do that was with the HDPE. This was a record-setting drill in the fact that the 4,200 feet was record. It's also was extremely deep. So we're talking about deep drilling. The channel is about 60 foot deep where this pipe crosses underneath the main channel. They went an additional 100 feet deeper than that in the directional drill. So at about 160 feet down was the depth that this drill took place. There were lots of different people involved with this. Of course, there were the owners, there are geotechnical companies, there are engineering companies. There's Garney Construction, who was the primary contractor on this. They did this as a design build. And like I said, the 42-inch pipe has been in for quite some time. They're currently in the process of adding about 11,000 feet of 54-inch SDR11, another 6,000 or 8,000 feet of 48-inch pipe to this to complete this. We're still about 3 to 4 months away from completion at this point. That's kind of just a quick rundown on it. You can see here it's showing all the different people that were involved, Garney being the contractor. They were in joint design build with Dewberry Engineers. Brierley did all the geotechnical work on this, which was quite extensive because of the very soft clayey soils that are deposited underneath here. What you're seeing in the picture here is just them setting, this is all the setup for the actual pull through. Let's see here. What have we got here? It's saying 8,000 feet of 42-inch pipe, but there's 5,700 that was actually done in the directional drill. The other was added at another point. What's unique about this drill is that the length of the drill, the angle of the bore, the depth and everything that was involved was, if they were just doing a pullback with it, it would have exceeded the strength of the pipe itself. So with Garney and Dewberry, they procured a pushing tool out of Germany that they were able to put on the backside of the pipe, and it literally would grab the pipe and it would push at the same time that the other side was pulling. And by doing that, they're able to not exceed the tensile strength of the pipe throughout the pool and make this historic long pool. The picture they show right there is actually just the fusion barge, all the pipe for this 42-inch line, and all the pipe that's being installed today is all being done on open water. The pipe is floated out on the barge and then lifted with the crane onto the barge. You can see there's a shed there where the machine is in, that they've pulled the cover off of the machine right there. But they can move that cover over the top so they're environmentally protected from anything that's going on outside. It's a pretty interesting process. I know you've got a little slide or, a movie here on this. I'm not sure where that is in the slides.
All right, you're good.
Yeah,
That
so we
one was-
bypassed that one because we're running out of time. But
Are we?
I
Okay.
mentioned,
All right.
Steve, that not only did you use the data logger, but you used some of your fusion text to help Garney. Is that correct?
That's correct. Yeah, on all the 42-inch line, they wanted certified welding techs to weld it together. So we had our techs do all the initial welding. Every 50th joint was tested by the. They had to cut it out and do the bend back test that we were showing there just briefly. And at this point, as forward, Garney is using all their own people to actually do the fusion and lay the pipe in. So
Right. So what we're seeing there, Steve, is that side bend test. How often did you do the side bend test? Because it's a destructive test. And you had some pretty big pipe there.
every 50th joint was what was required in the spec. So every 50th joint, or anytime a new technician came on the project, he had to be qualified through the side bend test.
Okay. Well, that's incredible. So there is a video. It's available on YouTube. Just search Garney HRSD, and I think you could find it there. Steve Wilson, great job. Thank you so much for sharing your knowledge with us. And I'm sure the project team really appreciated your knowledge on that HRSD crossing. All right, with that, I'd like to invite everyone to take a snapshot of this screen. And Alan, if you could come on and tell us how people get their PDHs today.
So, Peter, I'm glad you asked, because that's always what we get asked. There's a survey at the end of the webinar here once we stop it, to be able to tell us what your state is, what your name is, what your CEU or PDH requirement is. And that's the quickest way for us to be able to send you that information. This contact information page, feel free to contact everybody in that manner, not for your CEUs or PDHs, but everybody if you have any questions. So a lot of information here, pretty quick for you. So we're really appreciate your attention. Lots of incredible questions, really well thought out. So kudos to you, audience out there in the web world, for paying attention and listening to us and participating, as well as giving your time to the Alliance for this. We know your time is precious, and we really appreciate what it is that you attend and choose to attend for your continuing education with the Alliance for PE Pipe. So with no further ado, thank you for your time. We've got a lot more webinars this year in this series, and we really appreciate everybody that was on the call with us for these 7x7 case studies, and they certainly did run the gambit, Pete. That was a lot of information, and everybody did a really good job.
Yeah, speakers, if you like this format, let us know, and we'll keep doing stuff like this. With that, stay tuned for your PDHs, and we'll see you next time.